Hello, and thanks for clicking on this next Notch One production. Today, we are going to be factoring the difference of two squares. This is our fifth method of factoring that we're going to be talking about here. So let's get started and see what it entails and what we need to be able to do. So, to be able to find the difference of two squares, you have to recall your squares and your square roots. So if you remember from probably eighth grade or so, if I ask you to take 1 squared, that means 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, or 16. 5 squared is 5 times 5, or 25. Now we can keep going. Okay, obviously you can go as many numbers as you want, all right, in the positive realm. But that's if you square something. Now remember, square roots undo the process of squaring something. So for example, the square root of 1, when I ask you for that, I'm asking you what number multiplied by itself is 1. So what number multiplied by itself is 1? Well, 1. So the square root of 1 is 1. The square root of 4. What number multiplied by itself is 2? Is 4. 2. Because 2 times 2 is 4. The square root of 9. What number multiplied by itself is 9? Well, that's 3. What's the square root of 16? 4. The square root of 25 is 5, because 5 times 5 is 25. If I were to ask you something like the square root of 100, you should be able to tell me that's 10, because 10 times 10 would be 100. The square root of 81 is 9, because 9 times 9 is 81. So that's what we mean by taking a square root, okay? Now, you can also do it with variables. The square root of x squared. If I ask you to take the square root of x squared, well, what multiplied by itself is x squared? Well, x times x is x squared. So the square root of x squared, at least for now, is x. There's a little more to it than this, okay? But in this section, when we're doing difference of two squares, you really only have to understand that the square root of x squared is x. What about the square root of x to the fourth? Well, what multiplied by itself is x to the fourth? Well, now I'd need an x squared and an x squared to make x to the fourth. So the square root of x to the fourth is x squared. All of these square roots are what we're going to use to be able to factor the difference of two squares. Okay, that's what we're going to use. We're going to use that concept. All right, so these are all important. Okay, so to factor the difference of two squares, the difference of two squares, you're going to have two terms in your polynomial. Difference of two squares. Difference, of course, means subtract, right? So I'm going to be subtracting two terms, and they're both going to be squares. Okay? So to do this, the first thing you're going to do is check for a GCF other than 1. You have to do that first for pretty much every method. Factor out the GCF if there is one. Otherwise, you can leave it alone and just try to factor. Step 2, make sure that there is a difference between the two terms. They have to be subtracted. If they're not subtracted, you cannot use this method. Okay? And you're going to take the square root of each of the two terms, and then we're going to use the two square roots that we get to factor the polynomial. I'm going to show you how this works in just a moment. We can see it based on the pattern. All right? All right, now before we factor, let's go and multiply. So here are 3 different problems to multiply. So let's multiply through. We're going to take x times x and x times 5. So that's going to be x squared plus 5x. And then if we take the negative 5 times x and the negative 5 times negative 5, we get negative 5x minus 25. So now we combine our like terms. 5x minus 5x, that's 0. So we get x squared minus 25. And that's my answer. So now if you look, just look at what we get. We get x squared minus 25. There's only two terms, right? There's subtraction in the middle, okay? So you can kind of see where we might be going with this. Let's try the next one. If I have x plus 8 times x minus 8, x times x, that's x squared. X times negative 8, negative 8x. 8 times x, positive 8x. 8 times negative 8, negative 64. Combine the like terms. Negative 8x plus 8x is 0 again. You get x squared minus 64. Oh, look at that. There are two terms. There's subtraction in the middle. And each one of these, the x squared, you could take the square root of. Right? The square root of x squared, we just said, well, that comes out to be x. And the square root of 64, well, that comes out to be 8. Would you look at that? Okay. And then finally, let's take x plus 9 times x minus 9. X times x is x squared. X times negative 9 is negative 9x. 9 times x is a 9x. And 9 times negative 9 is negative 81. I got negative 9x plus 9x. That's 0 again. I get x squared minus 81. And again, I'm down to two terms with subtraction in the middle. And if I take the square root of each term, the square root of x squared, that's an x. And the square root of 81, that's a 9. So you can see the goal is we're going to try to start at x squared minus 81 and write it using this pattern, or x squared minus 64. Write our answer in this pattern. X squared minus 25, the square root of x squared, well, that's just x. The square root of 25, that's 5. Would you look at that? Using that pattern. Okay? All right. Let's take a look. Let's try to factor. We'll try to go the other way. Let's try to factor x squared minus 49. So the first thing we're going to do is we're going to check for a GCF. Is there a GCF other than 1? No, there's not. Okay, it's got 2 terms. All right. 2 terms, no GCF. We're going to try difference of 2 squares. Okay. To find the difference of 2 squares, we're going to take the square root of each one of the terms that are there. There's only 2. We're going to take the square root of each one. There is subtraction in the middle. There has to be a difference. Square root of x squared is x. Square root of 49 is 7. And now we are going to factor this. And you can actually see how this works if you, in your head, you kind of multiply it out. X squared would split up into x and x. And then they got to multiply to be negative 49. The square root of 49 is 7. So I'm going to use negative 7 and positive 7, because negative 7 times positive 7 is negative 49. And if I were to try to multiply this back, that's a 7x, that's a negative 7x. Add them together, you get 0x. That's why there's no x's up there. So this must be the correct answer. This is all done. Let's try the next one. Same thing. I'm in a scenario where I have x squared minus 36. Let's see. I got 2 terms in it. I'm going to look for a GCF other than 1. There isn't one. They are subtracted in the middle, so I can try the difference of 2 squares. I'm going to take the square root of each one of these. The square root of x squared is an x, and the square root of 36 is 6. So now I'm going to try to factor what I have here. X squared would split up into x and x, because x times x is x squared. The square root of 36 is 6. But when I multiply them, I have to get negative 36. So I need one of them to be a positive 6, the other to be a negative. Positive 6 times negative 6, negative 36. If I did x times negative, that's negative 6x. Positive 6 times x is positive 6x. Negative 6x and 6x is 0. That's why there's no x term in the middle. That's the right answer. Let's try this third one here. Now I have 9 minus x squared. I reversed the 2. Well, you can still do it. Again, we're going to check for a GCF. There isn't a GCF here. Okay. I'm actually going to show you 2 ways to do this problem. It is really something you should be able to do both ways. I'm going to try it like this first. Okay, so we'll say there's no GCF. They're subtracted in the middle. This is the difference of two squares. Okay, it's got two terms. I'm going to take the square root of each. The square root of 9, that's 3. The square root of x squared, that's x. Now I'm going to try to factor it. Now I got to be careful. The 9 is up front. So I'm going to put a 3 there and a 3 there. 3 times 3 will give me positive 9. But now I got to get a negative x squared here at the end. So the square root of x squared is x. So I need one of the x's to be negative, the other one to be positive. And that's the correct answer. That's one way to do it. The other way to do it is to say, okay, well, it's not in standard form. So let me put the negative x squared in the front. But the problem is you can't lead with a negative. So you have to take the negative out as a negative 1 out as a GCF. So you divide each one of these by negative 1. Negative x squared divided by negative 1 is positive x squared. Positive 9 divided by negative 1 is negative 9. Now I look inside. There are two terms. They're subtracted in the middle. So I can try difference of two squares on that. So the square root of x squared would be an x. The square root of 9 is 3. So the negative 1 comes down. That's the GCF. And then we're going to write what we have here. Now the x squared is in front. So the x and the x will lead. And they have to multiply to be minus 9. The square root of 9 is 3. So one of them's a negative. The other one's a positive. And this is the correct answer. Okay? So two different ways to do the same problem. Both are acceptable. All right, let's make it a little more interesting. 25x squared minus 49y squared. So now, if I look, I'm looking for a GCF between 25 and 49. But 1 is the only GCF between them. We have x squared there, 2 powers of x in that term, 2 powers of y in that term. I can't take any of them out because they don't match. There are two terms, 1, 2. They're subtracted in the middle, so I can try the difference of two squares. Now I'm going to take the square root of each term individually. The square root of 25x squared. When you take square roots, you can put them both, and you're multiplying. You can take both of them, put them in their own square root, do them one at a time. Square root of 25, that's 5. Square root of x squared, that's x. The square root of 49y squared, well, square root of 49, that's 7. Square root of y squared, that's y. So now I'm going to factor this. I got to get 25x squared in the front, and the square root of 25x squared is 5x. So I'm going to put a 5x there and a 5x there. 5x times 5x, 25x squared. Now I got to get a negative 49y squared using 7y. So that's going to be plus 7y minus 7y. And that's the answer. If I have 5x squared minus 5, I'm looking for a GCF. There is a GCF this time. It's 5. There's 2 powers of x there, but none there. So I'm going to take the 5 out. I'm going to divide both of these by 5. 5x squared divided by 5 is x squared. Minus 5 over 5 is 1. Okay, now I'm going to look inside. There are 2 terms in the parentheses. There's subtraction in the middle, so I have to try difference of two squares. The square root of x squared is x. The square root of 1 is 1. So bring the 5 down. That's part of my answer. It was the GCF. Just bring it down. And now we're going to try to factor the x squared minus 1. The x squared is in front. So I have an x here and an x here. And then I have to multiply and get negative 1 using 1. So minus 1 plus 1. There's my answer. And again, if I were to multiply this out, I'd get back to where I started. Finally, we have 16x to the 4th minus 81. So I'm looking for a GCF, 16 and 81. Nothing is in common between those two. I have 4 powers of x in the first term and none in the second, so I can't take any out. So I'm stuck with all that. All right, so now they're subtracted in the middle. There's 2 terms. I'm going to try the difference of two squares. Let's take the square root of 16x to the 4th. Okay, the square root of 16 is 4. The square root of x to the 4th is x to the 2nd. Okay? What times itself? X to the 2nd times x to the 2nd is x to the 4th, right? So what thing times itself is x to the fourth? X to the second. The square root of 81, that's 9. All right, so now we're going to go factor this. Here we go. We lead with the 16x to the fourth from 4x to the second. So we got 4x to the second in the front, 4x to the second in the front. Now, they're going to multiply to be negative 81, and I'm using 9. So we have minus 9 plus 9. Now, normally I'd say, well, that's the answer. It's all done. But this one is not complete. It's not completely factored. Look at the answer that you got. If we look at this first set of parentheses, you can do, it's got two terms. There's no GCF, but it's got two terms, and they're subtracted in the middle. So we can try difference of two squares again because there's an x squared up front here. So if we do that, the square root of 4x squared is 2x. The square root of 9 is 3. So this 4x squared minus 9 now has a set of factors. Lead with 2x. Got to multiply to be negative 9, minus 3, plus 3. This other set of parentheses, this other factor from the original equation or polynomial, 4x squared plus 9, I can't use difference of two squares on it. I can't use difference of two squares because in the middle, it's a sum. They're added. It's not a difference. They're not subtracted. So this method does not apply to this factor or this set of parentheses. So all I'm going to do is bring it down. And I have my answer, 2x minus 3 times 2x plus 3 times 4x squared plus 9. Okay, so that's factoring twice. You get your answer factors again, and then you have to factor it with the difference of two squares. All right, so you have to watch out for that now too. Okay, and that's it for this one. And as always, thanks for clicking.